Hello, everyone. Welcome to the EasyPower Thursday Refresher webinar series. My name is Jim Chastain. I'm the host for the session today. And before I introduce our guest speaker, as our habit, I'd like to run through a couple poll questions, get a little feedback from the audience as to your exposure to the topic. Again, there's no obligation as far as participating, but it would help our presenter understanding a little bit more about how to focus his presentation. So the first question is, what is your experience level with this particular topic? And we'll give this 20 or 30 seconds to get some feedback. As I indicated on my chat, this is the first time in a while that I've seen a difference between my cell phone time clock and my computer time clock. So if we were late starting, sorry about that. If we were early starting, sorry about that. Okay, it looks like we have a quorum on this. Here's how folks have weighed in on that topic. We appreciate the feedback. The next question is, just to kind of get some focus, what's the difference between, or is there a difference between bonding and grounding? And for me, this is definitely a not sure, so I'm looking forward to the presentation. We are on the West Coast, and we're still experiencing some air quality issues. Hopefully others are not as handicapped as that. All right, looks like we've got a quorum there. And it looks like, again, we have the right audience. I'm glad to see that. Our third question is, when using a monitoring device, what's the most important component? We'll give this just a few seconds to get some feedback. Again, there'll be, during the presentation today, you're welcome to enter questions on the question box from the webinar control box section. If we're not able to handle all the questions, we'll follow up via email with anything that we weren't able to handle live. So it looks like we're a little bit more evenly split. And then the final question is, have you had an incident where static discharge was a problem? Let's give this about 10 seconds more. It looks like everyone's chiming in. All right, here's how folks voted. Thank you again very much for your presentation or your participation. And at this point in time, I'd like to relay that over 30 years, Newson Gale has been manufacturing static grounding equipment for hazardous area industries. Our guest speaker today is the Western Regional Manager for Newson Gale. So I'm pleased to introduce Mr. Christopher Coughlin. Chris, the podium is yours.
Well, thank you, Jim. I'd like to say hello and good morning to everybody. Thanks again, Jim. Welcome to Static Discharge Awareness and Explosion Protection. Let me just set up my slideshow here for everybody.
Looks good.
There we go. Perfect. Again, Static Discharge Awareness and Explosion Protection. First, I'd like to, of course, thank EasyPower for the invitation to present today. I really appreciate it. Newson Gale, I know they appreciate it. Second, just another applause to you, Jim. Thank you very much for being the host today. And thank you, everybody who joined. I appreciate it. I hope you get something out of it, hopefully a nugget or two. Hopefully I can help with something along the way. Again, my name is Chris Coughlin, actually. It looks like Coughlin. I actually go by Coughlin a lot. I use it a lot because it's easier to spell that way. But it is a hard G sound. I am the Western U.S. Regional Manager for Newson Gale. I cover 12 beautiful states out here in the West. I reside and live in Phoenix, Arizona, actually in Mesa, Arizona. Nice and sunny as usual. Beautiful weather out here right now. I'd like to just give you a little brief overview about myself. I've led a pretty diverse career Over 25 years in the safety, chemical, water, wastewater, oil and gas industries. Over 25 years in sales, consulting, and advising. I've been an operator, a manufacturer, manufacturer's rep. I've been in distribution and obviously sales. I also have an 8-month-old. I have a 4-year-old and am married to a beautiful lady from Zimbabwe, Africa. We just celebrated our 10-year anniversary not too long ago. So that's pretty cool. So a little bit about Newson Gale. Newson Gale was founded in 1988, 30 years in the industry. Their headquarters and manufacturing is in Nottingham, UK. They have subsidiaries in the USA, Germany, and a joint venture in Singapore. They were recently, in 2016, acquired by Herbiger, their safety solutions group. A little funny story about that is you're going to see along the way, especially on these slides, you're going to notice that there's a insignia on the bottom. You'll see Newson Gale down there. You'll see Herbiger down there. You'll see IEP Technologies down there. IEP Technologies is Industrial Explosion Protection. So IEP in 2016 was in the process of purchasing Newson Gale, both standalone companies, both profitable, both in very similar type industries. IEP was more for suppression, ventilation of explosions, and obviously Newson Gale was more on the prevention via static. During that process, Herbiger came along and wanted to purchase IEP. Ended up purchasing us both. And what that did for Herbiger was just vamp up and made them stronger on the safety solution side and made it very, very strong on their breadth of products and solutions that they can offer anybody and everybody in that area of safety. So it was a good purchase, I believe, at the end of the day. Newson Gale specializes in the design, development, and manufacture of hazardous area static control grounding systems, devices, and accessories, all the way from simple clamps and cables all the way up to very robust monitoring devices. We also do education on static grounding and bonding, training programs, informal on-site surveys, and the like. We do webinars like this. We do speaking engagements, lunch and learns, demos, whatever it takes to help the customer learn more and become safer. A little bit about Herbiger to give you the overview of the bigger picture of everything that we do. The Herbiger Safety Solutions Group encompasses IEP, Newson Gale, and Herbiger. So they've got dust explosion protection, explosion prevention, engine explosion protection. Obviously, we're going to focus strictly on the Newson Gale side of it, which is my side of it, which is the explosion prevention, the equipment that goes into that, and the like. In other words, IEP offers a full range of explosion protection products, solutions, and services, such as explosion suppression, isolation, ventilation, and engineering services, but we're doing static. We also actually acquired another service to go along with our safety services, which is a spark control service, another unique industry along with the static industry. So very, very niche, very, very unique, very cool. So the first steps in protecting people, process, and plants from minor to catastrophic consequences, which would include loss of life, is awareness, understanding, and knowledge. One of the first potentially confusing aspects of providing a safe operating environment for employees, colleagues, and plant equipment and property is understanding and controlling static discharge. This webinar, we're going to discuss how to determine if your site's manufacturing or handling process has the potential to discharge sparks into a flammable or combustible atmosphere. I know that static caused fires and explosions result in expensive production downtime. A lot of times, these are overlooked because of cost savings. Band-aids are put on them. But these at the end of the day can cause bigger problems. And that's why I read this to you and make you aware of that. It's because awareness, understanding, and knowledge are the first steps. And we can't lose sight of that. Being non-compliant is not a way to control static. What can you expect from today? Well, you can expect to know what static is. You can expect to find out the sources and activities that cause static, what kind of industries you can find static in. What is bonding and grounding? It's kind of confusing. Some people think bonding is grounding. Some people think grounding is bonding. How do we assess, and are there solutions? What kind of solutions? Are there codes? What kind of resources? Do I get certified? Are there certifications? Who can I contact? Is there somebody at Noose and Gale? Are there other people that we can contact for questions if we have any? And then at the end, we'll take some questions if you have any. So maybe you're like me and you find yourself sitting at a table or an office pondering like these two individuals. What is static electricity? As they're thinking, what is static electricity? And it's shocking truth. Well, I know what my wife would say. She would say, it's when I shuffle my feet across the ground on a carpet numerous times a day and go up to her and kind of touch her and zap her. And she gets shocked and irritated and annoyed. And I continue to do it and do it and do it until she pushes back and says, stop it, stop it, stop it. Well, that's what she thinks is static electricity. And she'd be right. That is static electricity. It was built up in me. I kept on going against the ground and building and building and building until the capacity in my body couldn't take any more. So I had to go somewhere. And I knew that, but she didn't. So I would walk up to her and she was at a less capacity. So the discharge went into her. I think it's funny. She didn't think it was funny, but I would use the excuse as I was doing the research for work, because I am, because this is what I do. I do static. So static electricity is all around us. It's in the natural world, often a nuisance in our everyday lives, but it could be a major problem in the industries that we serve in, the chemical industry, the food and beverage industries, the oil and gas industries, all sorts of industries that might have a flammable or combustible being used in it. These are all industries that could suffer from static electricity. Here's an example of a nuisance from static. It's the doorknob. We've all probably had it. You walk up to a doorknob and your hand or your finger gets zapped. Or it might be vice versa. The doorknob is actually getting zapped from you. But nonetheless, something is being zapped. There's an imbalance of electrons. Something is shooting the other. So something is amiss. But here's an example of a major problem from static. These are the problems that can happen and do happen. And these are catastrophic problems. And then there's the scary secret of static electricity that we all forget about and don't think about. It's dangerous. And why is it dangerous? Because you can't see it. You can't touch it. You can't smell it. And it won't happen to me. This is the scary secret of static electricity. It doesn't happen until it does happen. You don't know you have it. You don't know you've built up such a capacity in your body until you walk up to that drum and try to pour something into something, and the static comes out, and the spark happens, and the explosion then happens, or the fire happens, or the near miss happens. It's scary. It can happen, and it can happen to you. It can happen to her. So what is static? Static electricity is an imbalance of proton and electrons. In other words, electricity is actually trapped electrical charge, positive or negative. It's trapped surface on the surface of material that have accumulated over time when an imbalance of static charge is present on an object. The object is said to be electrified. Again, what is static? Two dissimilar materials come together in contact with each other. They touch, they rub, and separate. It's likely that one will leave more electrons than it started with. The other will leave with less, thus eventually discharging static in the absence of a low resistance to Earth. As you can see on the right picture there, you've got the Earth over there on the left, you've got the protons over here, and you've got that static going back and forth. On the left, you can see the electrons and the protons, and you can see everything being transmitted. You can see the charge in the middle. That's all it takes, is that little spark to cause a problem. Here's a little graph of a static accumulator. You see the two atoms. They're separated right now at the top in number 1. They come down through number 2. They collide. The electron, they hit each other. They separate again. Well, now one is missing the electron. Well, now it only takes that one. 1 out of 500,000 to cause an incendiary effect, to cause an explosion or a fire. That's all it takes. 1 out of 500,000 atoms to cause that situation to be in effect. That's scary to me. That is a scary situation. And that's from the section 5.21 of NFPA 77. If you're not familiar with NFPA 77, it is the Bible, basically. For Newson Gale for sure, because everything we do at Newson Gale is NFPA 77 or better. But it is Bible for static. It is everything static. Sorry about that, folks. My clicker stopped clicking. So the sources of static, what are they? Well, it's filling, spraying, pouring, mixing, flowing, walking. It's movement. It's any type of movement. It's the movement of a liquid. It's the movement of a powder. It's the movement of your body. It's the movement of anything. You're accumulating static. Every time you move your body, you move a liquid, you splash, you spray, you pour, you're accumulating static of some kind. More elbows in a joint, in a pipe. In fluids, it's the amount of charge generated during the handling of processing, and is dependent primarily on the conductivity, distribution, and mobility of the ions, the flow characteristics of a liquid, including turbulence and velocity, filtration, bends, elbows, variables in pipe, diameter, and agitation are important parameters of liquid charging with static energy. Basically, anything that's causing it to turn, move, bend, expand, contract, any kind of movement to that fluid. Liquid or powder flow. Charging by transport. Results from charged dust, liquid or solid particles settling in onto a surface and transporting their charges to this new surface. The rate of charge accumulation is a function of the rate of transportation. The splash filling and spraying liquids are a common problem. So how is charge generated? Charge is generated by relative motion. Liquid flows in pipes. Powder falls down chutes. Walking across a floor. It's called the triboelectric effect on solids and powders. It's just a neat and fancy way to say friction, motion, pressure, movement. Some example applications would be tanker trucks and rail cars, drums, totes, other conductive plant items, static dissipative bags and liners. Some people call it FIBC or super sacks. See a bunch of drums in a probably a chemical plant of some sort here. This is a product that we have. It's called a Bond Ride Easy. You'll see a light on there. What that light's doing is indicating that you've got a good connection to ground, or a good bond, rather. And what it's doing is the bond is 10 ohms or less. NFPA 77 states that you need a 10 ohm or less bond to be at standard. So that light is indicating that you have that currently available to you. If that light does not go on, it means you're not at 10 ohms or less, and you're not at that standard. So if you didn't have a light and you just had a clamp, you would not know that you were at 10 ohms or less. You would basically have a false sense of security if you just put a clamp on that drum without a visual indication that you had your 10 ohms or less. And you see it every day. Most plants are just using clamps, truth be told. It is more expensive, obviously, to have a indication there, but it is more safety conscious to have that. And it's better for the operator because it gives them the visual indication, obviously, right there. This is the flame triangle, flammable vapors and gases. What you need to cause a flame or a explosion is an ignition source, fuel, and an oxidant. And for dust and powders, it's oxidant, ignition source, and the combustible dust, the confined space of the dust, and the dispersion of the dust. So what types of industries are we going to find this in? Well, it's probably a lot of different industries, I would imagine. You've got the chemical, you've got the pharmaceutical, paints and coatings, food and beverage, and these are just major line item industrial markets. You've got all the subcategories that might fall in these categories as well. Anything that might be under pharmaceutical, such as I don't know, people that make makeup or any other thing. We've got COVID going on right now. People that are doing all that stuff as well. So the antibacterial hand sanitizers, that would need it. So any subcategories that you might find in these industries, you're going to find somebody that's using some sort of flammable or combustible product that will probably need bonding and grounding at some point. You're also going to find it in asphalt and automotives. Where can electrostatic charge accumulate? All over the place. You're going to find it in isolated conductors like these two drums over here on the left. You've got this drip pan. You've got the metal rack. You've got the two metal drums. All of these things need to be bonded together and grounded. And then you've got these two people. These two people are charges accumulating in them as well. This liquid, this conductive liquid, don't know what it is. I mean, I can assume what it is, but we don't know for sure. Insulating powders, loose solids, that has to be, it could be something there. What other objects? Portable drums, road tankers, piping, rail cars, rail tankers, people, scoops, hoses, the FIBCs, the super sacks, or whatnot that we talked about earlier. And what causes the capacitance? Protective coatings, the product deposits, the rust. On road tankers, it's the rubber tires, the piping, it's the rubber, the plastic seals, the vibration pads, the gaskets. People, it's the soles of the footwear, scoops, the rubber gloves. Here's the capacitance of the objects themselves. This is what typical capacity in picofarad of what these pieces of equipment or people have within them, a human body, 1 to 200 picofarads. That's how much it can hold of capacity until it has to release it. And here you're seeing another explosion, another example of the potential of the problems that occur from static, from mishandling static, from not looking at safety protocols that might need to be in place at your facility that you don't think about. The bonding and grounding, railroad tank cars, sugar plants. So there's their food and beverage, sugar, very flammable. We talked about this earlier, and we took that grounding, that poll earlier on. What is bonding and grounding? Is it similar? Is it the same? Is it different? Well, it's very different, actually. Grounding is a connection. It's connecting one or more conductive objects directly to the ground through rods, directly to the earth. It's also called earthing. So you've got the mass of the earth, and then you put a rod into the earth, and you connect through that rod. That is ground. That is a true ground or an earth. Bonding is the act of connecting two conductive pieces of material, like this truck down here and this tote, together. You've bonded them together with a clamp. So you've got two clamps, and you've clamped the truck to this tote. Now you've bonded them together. In effect, what you've done is you've put them at the same capacity. You've made them the same potential. Now, you can't spark between the two, but now you can get a bigger spark off of one of them. You can hold more capacity by bonding them together, but you haven't grounded the unit. You may need to bond something before you ground it, like this, but you haven't grounded it. So you're not truly safe. You've just gave it more capacity to hold more charge. Again, another example of bonding. These two conductive drums, you've taken clamps and cables, and you've bonded them together. It doesn't eliminate the static. You've just made them the same potential. Grounding and bonding. A combination of grounding and bonding ensures all charge generated process is dissipated to ground earth. Charge cannot accumulate on a properly grounded and bonded process. So if you look at this picture again, this truck and this tote, which once was just bonded together, now they've added a ground rod and taken it to earth. So now not only are you bonded, but you are grounded. So you're safe. So now the charge that accumulates within the two is now not going to shoot outward, but it's going to shoot to the earth. Over here in this example, you've got this conductive drum connected or grounded to a bus bar or grounding bar, which is connected to an earth rod. So it's going through the bus bar to the grounding rod. So it's earthed. In this example, you've got two conductive drums bonded together, grounded to the bus bar, and then fully grounded to earth through the grounding rod. You wouldn't be grounded if this grounding rod wasn't in position. As it's pointing out, verified earth or ground. And obviously the optimum solution in any case is a direct connection between potentially charged equipment straight to ground, straight to earth, without the bond. But obviously there are, situations that you have to bond items together first, and that's okay. The optimum solution would be straight to ground. And the resistance there should be obviously less than 10 ohms, NFPA 77. So the steps of an electrostatic risk assessment. You need to use your MSDS or your SDS. You need to know your products. What are you using? Know your plant as well. Know what kind of processes you're using, and know your products. Electrical conductivity of the liquids. You need to know the flash point temperature of your liquids. You need to know the powder sensitivity to ignition, the MIE, the power volume resistivity, the explosion severity, the minimum ignition temperature, the MIT of powder, the thermal instability of powder. And only use equipment designed and approved to match class and division for hazardous locations. Newson Gale does only manufacture Class 1, Div 1, Class 1, Div 2 equipment. Most of our equipment, actually all of our equipment can actually go into Class 1, Div 1, A through G situations. So almost any situation that you might be in, we would have a solution that would fit it. I believe we are the only company out there that actually does A through G, but we do have solutions for all of it, Class 1 and Class 2. And again, assessing electrostatics, there are questions that you need to ask yourself, when you're walking your plant, walking your process, walking your facility, or walking with a customer if you're a distributor of some sort. Could there be a flammable atmosphere? Is there a flammable atmosphere? Can charge be generated somehow? Can charge accumulate? Could there be a spark risk? Could the spark have enough energy to ignite a flammable atmosphere? If you answer no, that's good. But if you answered yes to any of them, more risk assessment has to be taken. You might want to call somebody in to take a look at it. You might want to have your safety specialists on site look at it. You might want to even call Newson Gale to take a look at it. Who knows? At Newson Gale, we have this chart. It's called the 5 layers of protection. And within the 5 layers of protection, we separate it out into 3 families of products. The first one is your basic simple clamps and cables. Then you go into a visual. Visual is obviously something an operator can see. And then you go into visual and interlocking. Interlocking meaning that it will send the device or the monitoring system will send a signal to something, whether it be a pump, whether it be a PLC, a strobe light, or a siren. It'll send a signal somewhere to do something for somebody. So in the layers of protection, as you go up, you move up on the family of products. And level 1, you are looking at your basic, your simple clamps and cables. No visual, but clamps and cables. But you'll notice in level 1, it says ATEX FM approved grounding clamps. That's huge because ATEX FM approved are the best of the best. When you're talking about that, you're talking about things that are explosion proof. You're talking about things that are made of 304 stainless steel. You're talking about things that went through a very rigorous process from FM with pull tests, torque tests, biting tests, all these sorts of tests to make sure that they are going to last and do what they need to do. Because you can buy clamps anywhere, but if they're not FM or ATEX approved, you're just buying clamps and hopefully they'll work. And Godspeed, they will. But, if you're going to just do simple clamps and cables, do simple clamps and cables that are at least ATEX FM approved. If you're going to go on the lower end, at least go on the lower end of safety than the lower end of cheap. As you move up the scale, you're going to move up onto the the scale of monitoring with visual. Now, from my experience, operators love this because it's safety for them. They love the fact that they can clamp onto something and they can actually see a light. And the light is just showing that they have a bond. And the bond is back to a grounding point. It's not saying that they're grounded. It's saying that they're bonded. So the bond is showing I'm attaching this clamp to a drum, and I've got a light. And I've got a grounding point back at a bus bar, and it's showing me a green light. It's telling me, okay, I've got a nice 10 ohms or less bond between that bus bar and this drum at 10 ohms or less. That's significant. Doesn't mean I'm grounded because it's up to the facility to tell me if that bus bar is grounded. They have to run a test. I would recommend one probably every year, making sure that they have a good outside ground. But the visual is very peace-giving to the individual who's operating that process. Because if he's just got a clamp, he's just got a false sense of security that he's okay. And as you move up, you get into, like I said, the interlocking phases, but you'll have visual and interlocking. Now, when you move up to the number 5 level of protection, then you're talking about a very unique type of situation where we have these two sister pieces of equipment. One's called road tanker recognition. One's called an MGV, which is mobile ground verification. And what those are is mobile ground verification is a unit or a system that goes on a truck, like a vacuum truck, and goes with that truck wherever it goes, and it will actually validate and test ground, which is unheard of in in the industry, really. So it will validate ground. As long as you have a grounding point to attach to, it'll validate that it is a good ground that it is attaching to. It also will do a 10 ohms or less loop test continuously. The road tanker recognition is its sister product, and it's a stationary product that does a very similar thing, but it validates ground, but it does a capacitance check on the truck itself to make sure that the operator's attaching to a tanker truck. So it has to send a signal to the truck to make sure it's between 1,000 and 5,000 picofarads to ensure that they've got a truck hooked up as a safeguard. So very unique, but very safety conscious for the operators. So those are layers of protection for safety wise. And we do offer support services, training, and publications. We do static ground informal site surveys. We, free of charge, will come out and we'll assess a facility, your static situation, the process. You know, if you have a mixing process, we'll look at it. Loading, unloading situation, we'll take a look at it. We'll walk a plant with a safety operator or plant operator or maintenance guy. We also do operator training and awareness. We do webinars like this. We do lunch and learns, all sorts of different forms of education. We also speak at VPPAs. We've got an Ear to the Ground newsletter. We're certified in what we do with our NFPA 77, our ATEX FM approvals. We have many resources and codes that we go by. NFPA 77 recommended practice on static electricity 7.41. Entire chapter focuses on having all conductive objects bonded and grounded as step 1 in protection. 74131 references 10 ohms between conductive paths, which I've mentioned a couple times in the presentation. That is the bond between things. You always want to have 10 ohms or less. You don't want to have above. That is the recommended practice. 7416 mentions pressure type clamps for penetration on a coating. Again, ATEX FM approved clamping to make sure that we go through that metal to make sure that we have that penetration. 684 mentions self-testing clamps and systems to continuously test resistance to ground. Again, that's the 10 ohm or less test. We have IEC 6007932. It's the international code. We also follow the UK, Germany, the international, obviously the Europe and Japan, and the US NFPA 77. We also go by American Petroleum Institute API RP 2003 and 2008. Certifications and approvals, SIL 2, ATEX, FM, ISO 9001, IEC. As you can see, we've gone through a lot of trouble to try to be the best of what we do and keep everybody in what we do safe. We care about the individuals that we see. We care about their facilities, and we want to make sure that everybody that goes into a facility gets to come home the same way they came in. So that's the nuts and bolts of the presentation. I do open the floor up for any kind of questions that anybody may have. I just want to finish with our value proposition, which is we just want to let you know that we have technical support. Our standards and our product knowledge is unheard of. We really try to go above and beyond for our customers and anybody that wants to learn from us, even if it's not a buying customer. It doesn't have to be. It's just somebody that's intrigued by safety and somebody that just wants to do better by the safety protocols on static. I thank you, and I appreciate it.
So, Chris, this is Jim.
Yep.
We got a few questions coming in.
Okay.
The first one says, what distance between bonding points and a fully grounded and bonded system is recommended?
So that's a tough one because it's going to be dependent on the resistance, obviously, and if you're using a straight cable or a coil cable, because a coil cable can do a little bit longer distance because you're not touching the ground. It would be easier if there was an actual application. Maybe this is something I could take offline and maybe discuss directly with the individual.
Okay. The next one is the IEC has several grounding methods. TNS, TNCS, and NFPA 70 recommends grounding and bonding. What is the underlying reason for different methodologies? We're going to ask tough ones here.
Yeah, that is a tough one. It's a good one. And you know what? I don't think I'm the perfect person for that answer, but I know who would be. Can I get that person's information? Because we actually have on this list here, on this map, Richard Puig, you see in red. Mm-hmm. Richard Puig actually sits on the board of NFPA 77. And I bet you he would have a very good answer for that, better than I could give.
Okay, and then any questions that we are not able to get to during the session, we can respond via email.
Absolutely.
Another question, and this is specific to a company's training ability. Do you offer certifications for online training per the standards IEC and NFPA 7 for static electricity?
No, I don't think we do.
All right. The next question. What about grounding of the steel building itself? What is the grounding requirement in terms of, I'm assuming, the electrical system of the building itself, steel building? Yeah.
Well, we don't do anything to deal with electrical systems itself. All we deal with is static. So the steel building wouldn't even, I wouldn't even know where to even talk about that. Because you could build up a lot of static in that steel building, I'm sure, but you're also going to have probably a lot of breaks, a lot of buffers in there with bolts and seams and caulk. But we don't deal with that kind of stuff, so I really wouldn't have a legitimate answer for that, because
All
all we
right.
really deal with is the static from flammability situations.
The next question is it goes to, I think, some of the pictures that you showed.
Hmm.
How did they know that the static spark actually started or triggered the explosion that they was in the image?
I believe it's because they did the research on it. I think I would have to go back and find out, but I believe because they were older images that the stories have already come out and the investigations have already been concluded that static was the cause to those explosions,
All right.
or at least part of it.
Mm-hmm. Here's another interesting one. It's known what types of shoe sole material either collects or
Mhm.
helps prevent buildup of static electricity on a person's body. Is there a
Yep.
recommendation or a feedback on that?
Well, yeah, there are ESD type shoes out there. And depending on the type of facility you're in, if you're in a pharmaceutical type situation, they're going to make the recommendation to you. And as a matter of fact, Noose and Gale actually sells something called a soulmate, which is like a soul tester. And they'll test the soles to make sure that it meets the requirement of whatever type of shoe, because there's two types that will be allowed inside, I think. There's two different data points that they use that are allowed into facilities.
The next
And
question.
you would have to set the requirement to meet that that data point or that parameter.
So the next one is, how do you ground an HDPE pipe? This pipe builds up a very large static charge.
You wouldn't. You can't ground plastic.
Good luck, Ken. That was from Ken. Does
Yeah.
multi-point grounding to a facility cause problems despite having heavy bonding or having bonding?
To a building?
Multi-point grounding in a facility. Yeah.
Well, I guess I would need more information on what they're bonding and grounding.
I think it's kind of like the first question is the distance question.
Yeah. It would be, yeah, it would definitely need more information to give them a real answer.
Is there a requirement for a specific electrostatic potential as opposed to a solid ground?
Mm. Is there a standard for it? Is that the question?
Is there any requirement for a specific electrostatic potential? It looks like they're a measured potential as opposed to just verifying a solid ground.
I don't think so. But I don't know if I'm understanding the question perfectly well. But I don't think so. But if I could get that contact information, I'd rather know if I'm answering the question correctly.
All right. Another one is, does static discharge is related to NEV, neutral to earth voltage?
Not that I know of.
Well, there were some good questions in there, Chris.
There were some good questions.
Yeah,
in there.
you'll have a list of all the questions, and we'll do a Q&A response to everyone's email.
Oh, good. Yeah.
So I thank you very much for the presentation. I think we've got several attaboys here on the list as well. And
Oh, good.
I think that kind of closes out our time. And
Well, I appreciate it. Thank you.
And thanks to everyone for attending.
Wonderful. Thanks, everyone.
So long.